Hello. Welcome everyone to another video or stream. Today we have, as the title says, a GTX1060 I just bought. I have not looked at this. I have no idea what condition it's in. The core could be missing, the RAM could be missing, everything could be missing. We don't know yet. Alright, this is what it looks like. It's a GTX1060. A bit scratched up from the top. Dirty fun. Amazing. I can see some VRAM chips, so I guess not everything is stolen, at least. Alright, let me take my beautiful iFixit screwdriver. Shout out to Saber. And yeah, those screws are not tight at all. Someone's definitely been in here. Now, please, no cracked core. Or just be there and not be cracked. Please. If it's cracked, it will be the shortest live stream ever. As usual, I don't have anything else planned. So. Okay, the core is here, so that's good. No one stole it. I'll actually use tweezers for this, because I'm very scared I'm gonna break it. This connector is broken in the past. Alright. Now it looks very similar to the 960 that I have recently done and took apart, but a bit different. Alright, let me wipe off the thermal paste and see if it is wise to continue. I think it is. I don't see any cracks, anything bad. Ooh, thermal pads, fancy. It wasn't there on the other one. Alright. Let me take my great multimeter and we shall see what the resistance is. Now, okay, core should be low, maybe even less than 1 ohm, 0.2, alright. It's very low, but that's normal for these. This should be 10 or more, 40, excellent. So the VRAM is not shorted anywhere. Now we try 12 volt. 12 volt is 190 kilo ohms. That's alright. Now we get, not sure which one is which, but one of these is ground, okay. So this is 12 volt auxiliary. That's alright also, so that's good. Okay, so that's really good that we have that. Yeah, so we have no short on 12. We have no short on RAM. No short on core probably. I mean, it's really low, but that's what it's supposed to be. It's 0.2, but if I try copper, it's gonna be 0.2, so I guess, yeah, maybe my multimeter can't measure that low. Actually looks quite alright. Now for the visual inspection. Wait, what the hell is... Oh, come on! Okay, I see flux under the core. God damn it. And here I was thinking that, yeah, this could be starting to look, could be good. Oh, there's flux under the core. Is there the lamination? Who knows? I don't know if all of those connected. We'll see under the microscope in a bit. That's not a good sign. That's really not a good sign. Someone reflowed this card. Reflow does more problems than it fixes. Should not do a reflow, should do a reball. Alright, let's see. This will be probably something. Alright. This will be 3 point. This will be pad. No, this is ground. This is ground. This is gonna be 3 volt. 3.3. That's kilo ohms. That's alright. The first pair of data lines is 10 mega ohms. That's normal. Alright. So that's good. Holy moly! That's a really ripped trace right here. You cannot see that yet, but oh, and there's so much corrosion everywhere. There's rip traces, corrosion, all that good stuff. Okay. No, not great, not great. Alright. But no shorts, from what I can see. The only thing that I'm worried about is I am having really low resistance on the core, which means either the core is shorted from the reflow, or it's just supposed to be like that. I'm gonna actually check my resources to see what resistance everything should be. Alright, I don't see anything for the 1060. I try to find the board view. Alright, I'm gonna load up the board view, and I will see. And yeah, of course it cannot be that easy. It's gonna be somebody's attempt at a reflow. Alright, I got the board view loaded, and it seems like this is for this one. Unfortunately, I don't know. At least it doesn't seem delaminated. That's the one good thing. At least here. Okay. Time to get to the microscope. I'm gonna try to connect it. We'll see how it goes. Microscope is a bit funky. Sometimes it works, sometimes it doesn't. Yeah, I know. Right. I'm gonna switch you all in just a second here. Thing I gotta do is do this because it's not really stable. Perfect. Now I do this. And I should be now able to just switch. Is it working? Probably. Yeah, alright. Got the microscope view. Now let's see what kind of damage this is. Try to get the more bright. Ooh. Yeah, so this is, I say, not ideal. Not ideal at all. Take a toothbrush, try to clean it up a bit. You can see someone's already tried doing something to it. Right now I'm just scrubbing off all of the dirt here if I can. It doesn't seem like that's very effective right now. Take my microfiber, some more sprays. Is it a bit better? It still doesn't look great. I guess I have to come in with the tweezers. And try to pick out the grime between these components. Yeah, it's like really on there. It's hard to see, it's really hard to see. Yeah. It's sticky. I don't know what this is. No, not good, not good. I'll try to see if I have any better tweezers. Alright, there they are. Well, these are actually so thin they can fit between those components. So I can scratch everything off relatively easily. I wonder what happened to this poor GPU. Probably missing a resistor here. Trying to clean the sticky gunk here. I'm gonna come with the IPA and try to scrape it off again. Yeah, not looking great so far. All right. So, trying to orient this better. Can I do more light? I mean, I can. It doesn't really make it any brighter. All right. Now, I'm gonna check with the board view and see exactly what these resistors are supposed to be, and see if they are still good or they need replacing. If they are the same value or it's more, I think that means it's okay. But if it's less, then that means it's bad. Right, so this is the board view. This is this component. Now we have a couple of resistors. This should be a 0 ohm. Let's measure that. That's an open line, so already not to a great start. So this 0 ohm resistor is cooked, this one. Alright, I'm gonna have to replace that. Let's see the rest. There's a cup there. There's what's this for thing? Oh, it's a capacitor, that's alright. Then these three, supposed to be 4.9, 0, 10K. Okay. 4.9 is $41. This was supposed to be 4.99, and it is in fact, let me measure once again. It shows open line. Yeah. 38 kilo ohms. Okay, that one is also bad. This one is supposed to be 10K, and it is 42K, and this is supposed to be 0. Okay, this 0. There's one resistor that actually survived, and it's this one. Now this is a very much cracked capacitor. Is this shorting? Of course it's shorting. It's a shorted cap. Okay, so there's already so much damage, but not to worry. I'm gonna try to fix it all. Alright, so first things first. I mean, what I think is, this is everything that's wrong with the card, and the reflow was unnecessary, probably. That's what I'm thinking. Right. I'm gonna change to my small tip for my iron. And we will start with removing the shorted capacitor, because we don't want any shorted capacitors here. Shorted capacitors are bad. I'm gonna come in with a tiniest amount of flux on the shorted capacitor right here. I think it's not that tiny when under microscope, but in the real world it's very tiny. short. That cap is gone. Now let's see if that short is still there, or did we just get rid of it? Open line. Okay, I got rid of the short. Okay, that's one problem down. About 1,000 to go. Oh, there's so much missing stuff. Everywhere, ripped components all across. I don't know what is it with these boards, but every single time I see a red board like this from MSI or Lenovo, it's always freaking ripped. Half the stuff of the board is ripped. Alright, what we're gonna do now is we're gonna take a donor board without the core, the dead core. Yeah, I'm gonna take this one. This is which one is this? This is the... Okay, this is the one with the untraceable short. Perfect. It's a GTX 960 donor board, and we're gonna steal stuff from it. I just need to... would be better if I could. I have to have two board views open simultaneously, and I try to do that. Alright, and what I need is okay, first I'm gonna do the resistors. Those are the most important ones. I need 10k resistor, a 4.9k. Okay, so first 10k. Alright, of course. I cannot just search for the resistor. Alright, this one is 10k. If it exists, it exists, alright. So I'm just gonna steal it. From this donor. Alright, now I got this donor resistor. I'm trying to move it so that you guys can see what I'm talking about. Alright, and so this is my donor resistor. Now it's extremely difficult to do this actually. This may seem easy, it's actually really hard. Right, I'm gonna try to move it a bit out of here so I don't accidentally knock it over. Right, so this bottom one should be 10k. No, this one in the middle is supposed to be 10k, right? I will compare and check because yeah, the second one is supposed to be 10k.
Right. Got it removed. And now I have to first clean the pad. I was almost about to solder this resistor upside down, and I was thinking like, why is it a capacitor? Just underside. Right. Now I need to solder on the other side. I think this side is alright. Kinda sucks, doesn't it? The quality of my recording. I'm sorry. Right, now this should be 10K. Will it be 10K? 10K, alright. So this is good. Now the one below it was 5K, 4.99. And it's very much not. It's 93K. So that's bad. Now I need to find 5K resistor here.
Aha, to fajne. To fajnie, to fajnie. Okay, this one is 4.75, which is almost 5. So I think we're gonna go with that. I think it's gonna be close enough. Probably. I don't think I'm gonna find closer one than this. Right. I got it. Now I need to take it down from here, remove the bad one from here. No, I accidentally took the new one with it. Oops. Well, nothing to worry about. I'm just gonna get this new guy back onto its pad. Nothing happened. All right. This is
Ow, what the heck? Okay, sorry, I have to move it for just a tiny bit. Because something's not right. It shouldn't be like this. Oh, oh come on. I just blew on the resistor and accidentally blew the other one away. Did not mean to do that. Okay, I think I'm happy with that. How that looks. Yeah. Now for that 4.99 I'm gonna have to find another candidate because I literally blew it off.
Alright. So unfortunately, I don't think it's gonna get better than this. The closest one I can find is 5.5K, and if it doesn't work, I mean, I guess there's nothing else I can really do. Oh, wait, that isn't even populated on this board. Oh no. Oh, wait. Is this populated? This is this section, it's not. Oh, but this one is. Yes, alright. There's a 4.99. I cannot lose this one. This is the perfect match. To be really careful now not to damage this resistor while removing it. Right, resistor removed. I'm gonna leave it on the table for now. First I'm gonna prepare the pads, tiny bit more flux, clean the tip. And time to get the tiniest little solder on the iron. And now just touch the pads. They're nice and ready for the new resistor. That's perfect. Absolutely perfect. Of course, now somehow I have two resistors on my table. Let me see. Is this the one I want? $49K, and this one is 0 ohm. What? I was pretty sure this is saying, yeah, it's 4.99K, but my multimeter is saying it is it's really hard to measure when the component is so small. My God, this is frustrating on so many levels. $49.6K. I was so sure it was. I mean, on the board view it says it's 49. That's 4.9, I mean.
Yeah, this is a 0 ohm. Huh. What? I'm gonna trust the board view. I'm just gonna solder this 49K1 and we'll see what happens. Just gonna place it carefully. And try to get a good look at it with a microscope instead of my eyes. Alright, I think that's good enough. Just gonna take this tiny thing off here. Alright, I'm gonna check again. Do I have, I guess, 49K now? Yeah. Ow! I hate that this is very much charged. Like because the crap TV I'm using, it charges everything that the ground is connected to. So the ground is so messed up. And so what happens is that the ground is not actually ground, and every time I touch the grounded thing, I get zapped. $49K, yeah, that's the decimal where it's supposed to be. Alright, it's good enough. Huh. Alright, that's 0 ohms. I thought it was broken. Now, there was also a cap that was shorted that I would like to there's 1, 2 caps. How about that second cap? Is it shorted? No. Alright. Third from the... Oh. So that shorted cap... Was that not a capacitor? Are you kidding me? Or wait, was... No, the capacitor was here. Alright. Right? I don't know anymore. There's a 1 microfarad cap here. And I'm not sure if there was a 0 ohm there or not.
I better solder a 0 ohm there. This is a 0 ohm resistor. You know what? It's a this is 0 ohm. No, this one's an open line, so this was the bad 0 ohm. Right? So hard to measure the small components. Yeah, this one's the bad 0 ohm. Alright, so since this is a 0 ohm, I think I can just short it. Shouldn't be any harm in doing that. Where is the thing? There it is. It looks like such a mess. Alright. So, let's try to short those two pins. Not that easy to short something when I want to do it. But of course, as soon as I stop trying to short something and try to do something else, it automatically shorts. That's just how it is. Alright. I have the tiniest bit of copper here. I'm gonna try to pass this off as a 0 ohm resistor. If I can, but that's not the tiniest bit, that's still way too large. Okay, I'm gonna have to find my 0.1 millimeter enamel wire somewhere. There it is. Alright, I got it. Okay, now I just have to bridge this. What I'm thinking now, ow, crap, I hate this. I got zapped again. What I was saying is that what I'm thinking is happening is that when I thought that was a shorted cap, that was actually a very damaged 0 ohm resistor that looked like a capacitor. Just need to confirm. Where's my tweezers? I just, out of camera, I have to compare. Is that soldered enough? Yeah, that's good. Alright, I'm not gonna touch that. Or should I replace that cap already? I don't know. Okay, for now, I need to see, because this, let me try to navigate to where I was. Sorry. Okay, This is here. I need to go up, up, up. Okay, so this is the area we're working on. And now this is a ripped trace. There is nothing here. So we're gonna have to use our board view to see what traces were there and see if we can recreate them. Okay, so this is 10k to ground. This is... Alright. I'm gonna do now is I'm gonna check the last 3 resistors. So this one, this 0 ohm one, should be going, hold on, this and here, there up here. Right, so this one is connected, that's good. This one should be grounded. Pretty sure that's ground. So that's good. And this one should be going to 1.8 HV VCC. So this side of the cap should be going here and over here, I guess. Yeah. And from what I see, we're simply not doing that. Oh wait, so what? Is this not ground? Yeah, this is ground. And this is supposed to be, there's supposed to be a path between this, this, and there's not. 1, 2. Okay, that's weird. Yeah, this works. Oh, there's a bit of crap on my probe. Okay, so that's not working. Hard for me to show anyone anything. Basically, what's happening is that this point and this point should be connected, and this point should be connected to the network, and the other point should be connected somewhere, yeah, here. But it is not. So that's weird. So that's either
this. Let's try. What if in ohms? Like 5, 6 kilo ohms, 7 in rising. Between those two. It's actually pretty weird. Okay. I can see that the trace physically should be like that. This should go there.
So I'm just gonna recreate that and hope for the best. Alright, so we get the wire, we get the iron. Alright, now for the I will connect. I'm sorry, I have to get this away, but I'm just too afraid that I will touch it with my hand, with my head, and get zapped. I don't like getting zapped. It's really just an unpleasant feeling, if you will. Right, let's now see if everything is what it should be. Oh, now magically everything is just how it should be. Alright, that's nice. So we fixed a problem by doing this jumper wire here. Now there's another trace that is very much broken. It's going from here to here. Yeah. Alright, so let's see what... This is an inductor. Going through 1.8 to 1.8.
Oh, and there's supposed to be a capacitor here. Oh boy. Alright. So, let me recreate that trace. Try to... Right. I'm getting to scratching. Now use those tweezers for that. Don't have a grinding pen yet. I hear some mice in the background. But I got rid of them. I haven't heard from them for a while. Seems I have not. I have to battle them again. I thought I got rid of them this time too. I guess I hadn't. Yeah, I mean, if the main 1.8 volt is disconnected, then you're not gonna see any picture. And unfortunately, to the guy who reflowed or tried to reflow the GPU, reflowing it will not fix a 1.8 volt missing issue. That is not... I mean, it might in some cases, but just look around the board first, please. For doing such things, like reflowing. Reflowing is dangerous, really dangerous. Not for like physically health, but for the GPU. You could have delaminated the core very easily. All right. That should be a happy 1.8 volt. There. Alright, so from what I see, there's a missing cap on the PCIe lanes. Although lots of caps can actually be ignored. These ones cannot. I mean, ignored like short term. Don't ignore caps forever. Not a good strategy. Now I know, no cap is better than a shorted cap, but you have to replace them eventually. Alright, and now I get the donor and I borrow a cap from it. Oops. I don't want to mess up the rest of the caps just by putting another one there. Alright, and from this side, that's perfect, I think, right? Yeah, I think it's just right. Alright, so I have this sorted. I'm gonna take a quick inspection again, just to see. So we have this sorted, we have this sorted. Do we have any other like resistors that are ripped? Any other alarming thing right now? There's a lot of liquid damage over there. I'm gonna go scrub that really quick. I'm looking for ICs that are blown up. Looking for shorts. On the top as well. It looks really clean. Now I'm gonna see if there's a short on the 1.8 rail. Since we just uncovered that, yes, that is the 1.8 rail. Doesn't seem that there's a short there though. Yeah, it just beeps once. Alright, so we have the PCIe cap sorted. We have that sorted. We have yeah, this mess around whatever this thing is. It's probably a buck converter of some sort, right? Is it? It's probably a 1.8 volt buck converter from what I'm looking at. Probably. We will see. Okay. Now, what I'm gonna do is I'm gonna actually take some IPA, and because there is quite a lot of liquid damage here, I'm just gonna scrub that down. Sorry I'm not showing it, but in the microscope it's not easy to do that. But you know what, I'm gonna bring it as high as I can and I'm gonna try. Can you see this? Yes, you can. This high microscope view is actually pretty nice. I'm gonna scrub this down of all of the liquid damage that was here before. It will be gone. In every resistor, every capacitor. Alright, now I take a microfiber. Okay. I mean, it looks a lot better, that's for sure. There's probably nothing shorting now. Alright, we have the main two traces that were destroyed before reconstructed. There's still a bit of caps and stuff that I'm not gonna be worried about right now. Yeah, it's a capacitor. I'm searching if any of those are actually resistors, because missing cap is bad, but it will work without it. A missing resistor though, that's the real issue here, if there is. Okay, everything for me looks absolutely fine for now. What we're gonna do right now is we're gonna reassemble the card, new thermal paste, and we shall see what kind of error it gives us, and we'll go from there, if it gets detected at all. Find the thermal paste somewhere. It's just here. No, it's not. Of course it's not. Where could it be? Maybe it's fallen down probably somewhere.
is turning into Gauzy tries to find his thermal paste. Oh, there it is. It's right, of course it's right next to everything. Right. No, this is not the perfect amount of thermal paste, but it is an amount of thermal paste sufficient. Alright, that's gonna be more than enough. Plug the fan in. Alright, screwdriver. We'll switch to the iPhone view in a minute. Maybe I can do that actually right now. Alright. I am gently getting the microscope out of here. Alright. So this is the GPU. No, don't worry, I'm going to, if this actually works, I am going to take the things, take this wire and coat it with protective coating. This is not like the final result. Alright, we'll now try to position this so you guys can kind of see the display a bit. It's always a mess with this, I'm sorry. It's infinite. It's infinite. Alright. HDMI 2. I'm gonna put this card in the test bench. Oh, come on, it's too long. Oh man. Come on, really? Can I get this card, this hard drive cage is what is blocking it. I'm gonna try to get it out. Oh man. Oh, come on, everything is falling down. No, the hard drive case is riveted in. I thought it was like removable. No, of course it's not. We love Dell. We all very much love Dell. Although I may be able to actually squeeze it in. Try hard enough. Oh, wait, actually. I'm so struggling right now, but I think I got it. Holy. So. I mean, I think it's in. It's in. Just plug it in.
actually got it. I plug in just the keyboard, is the essentials, and the HDMI, if I can. Where is it? There it is. All right, moment of truth. The fan of the card is not spinning. Not a great sign. I don't see anything on the screen. I'm gonna switch over to the onboard. See if we're in Windows. Huh. Well, that's even weirder. We're neither in Windows or in this. So I guess it's recognizing it as a display adapter, but it's a black screen. Does not put anything. All right, I'm gonna take some measurements. Do we actually get the 1.8 we just repaired? We do not. We don't get 1.8. We get the 12. We get 12. Alright, so that's gonna need a lot more diagnosis. And the problem is that I don't actually have time for that. There's a big storm coming, and I have to get back home quickly. So if we don't get 1.8, I'm guessing we don't have core. We don't have core. Check. This is memory. Memory can be checked. Now I'm gonna rotate it so it's just like this. All right. We have memory. We don't have memory even. All right. We have 5 volt even. There should be a chip here and here, and this should be 5 volt. We have 5 volt, we have 5 volt. So it was like 5 volt, we have 3.3. Okay. Like I said, I hear even more thunderstorms. So we're gonna continue this. But right now I'm gonna have to end the stream. So yeah. Goodbye.